Welcome to Dayla's class, brought to you by Alondra, Sofia, and Carmen. Have you ever thought about how much air weighs in a classroom, or even in any room in general? Well, today we're going to find out. We will also be learning about buoyancy. More on that a little bit later. For this activity, you will need the following materials: a pair of scissors, a dropper, a piece of wire, a 2-liter bottle, and also enough water to fill up your bottle. You will also need a paper and pencil to follow along with the math or to do math of your own. We will start the activity by calculating how much air is in a room. For this, I will be using the dimensions of the classroom I'm currently in. The dimensions are as following. Length is 13.5 meters, the width is 9.25 meters, and the height is 3 meters. Using these dimensions, I will calculate volume, mass, and weight. I start by calculating my volume. For volume, you will need length times width times height. In this case, it would be 13.5 times 9.25 times 3, which gives me to 374.625 meters cubed. Up next is my mass. For the mass, I will need the volume, which I just calculated, times density. In this case, density of the air, which is 1.205. My mass ended up totaling up 451.423 kilograms. Lastly, to calculate the weight, I will need to take the mass times it by gravitational pull, which is 9.81. This will give me a total of 4,428.46 newtons, which is about 995.55 pounds. That's right, there's 995.55 pounds of air in the room I'm in. Now that you know how much air around us weighs, imagine how much water around a scuba diver weighs. What do you think scuba divers use to help control the pressure from the surrounding water? To learn more, let's get started on our activity. Start by taking your dropper and cutting off the tail. Up next, take your wire and wrap it on the tail of your dropper. It should look like this when you are done. This is called a Cartesian diver. To test out your Cartesian diver, place it in a cup of water. In a best case scenario, your Cartesian diver should be neutrally buoyant. Buoyancy refers to the ability or tendency to float in water or air or any other liquid. So if something is neutrally buoyant, that means it neither sinks nor floats. Using your cup of water, try to experiment to obtain a close to neutrally buoyant diver. When you are done, you will need to place your diver into your 2-liter bottle full of water. Try to fill up as much water as you can, and once your diver is inside, put your cap on. Make sure that it's tightly sealed. At this point, your diver should be floating towards the top. But what happens when you add pressure? Let's take a look. Pascal Law states that pressure applied anywhere to a fluid causes the force to be transmitted equally in all directions. When a bottle containing water in Cartesian divers is pressurized or squeezed, the pressure within the entire bottle in the Cartesian diver is increased. Archimedes' principle states that the buoyant force is equal to the weight of the water displaced. Therefore, an object sinks if the weight of the water displaced weighs less than the object, or the object floats if the weight of the water displaced weighs more than the object. The Cartesian diver sinks because the density is increased when the water is taken up to the dropper and the volume of the air decreases. So, what do you think about today's activity? Leave it down in the comments section. And before you leave, I have something to show you. Do you remember the snap peas that we planted in week 2? Well, this is them now. They have definitely grown a few inches. Let me know how your plants are doing. Have they grown? Our green beans didn't make it. But that's okay, I'm just happy that one of our plants were able to survive. Let me know in the comment section if you have any questions. And as always, thank you for joining me today.